Good morning and welcome to Into the Terminal, episode 51. Today we're going to be talking about how to troubleshoot performance on Red Hat Enterprise Linux. So let's share out our terminal. And Scott, you want to start talking through some of the tools we're going to look at today?
So, like always with the troubleshooting episodes, we'll start with a series of tools that we will use later in the episode to actually troubleshoot real problems. And I see that Eric is already sharing Top. Top is a great tool for getting a snapshot that is updated every few seconds for what's happening on your system right now. So the top portion of the top output, man, that's a lot of ways to say top, is giving you some information like how long the system has been running, the load average, which is the CPU run queue size average, that is 1, 5, and 15 minutes. And then they also do some like logarithm adjustments to account for spikes in those time periods. There's a little bit on system information like CPU utilization, the memory utilization. And then down at the bottom is the list of processes, and they are first sorted by the percentage of CPU they're taking, and then by the percentage of memory they are taking. And then, so it'll refresh every few seconds, and you can see the topmost expensive processes running on your system. And then Q will quit out of top.
Sorry, my terminal kind of goofed on me. That's what I get for resizing it on air. So that first one was top, and you can get in there using just top. Second one that we wanted to talk about was free.
Yeah, so free gives you just the memory information and memory utilization on your system. One of the things to note on Linux systems specifically is that you will notice that the free memory is generally rather small. This system was freshly booted, so we don't see that yet. But the reason that it's generally fairly small is because the Linux kernel will use a lot of the available RAM for buffers and caches. And if you end up needing that RAM for programs, it will deallocate memory from the buffers and caches to make it free for applications again. But it is not unusual to see a very small number in your free. But what you want to do is also look at that buff cache line or buff cache field, because that is also memory that can be utilized for application memory. So really, when you're calculating how much is free, take the free field. A good rule of thumb would be to just add the buff cache, and that's really about how much free RAM you have on the system. So a lot of people that I've run into over the years will freak out when they see a really small number for free, not accounting for that aggressive caching that the Linux kernel does for memory management.
Next tool we want to talk about is vmstat, or Virtual Memory Statistics Reporter.
And so it shows a lot of the same information as top and a lot of the same information as free, but then it gives a little bit of extra information on how some additional subsystems are being used, specifically the swap in, swap out, and under IO, blocks in and blocks out. So in addition to giving you the free buffers and caches and used memory, it also gives you like how much in and out you're doing in your swap subsystem and how much in and out you're doing on your IO subsystem across devices. And then at the end, it gives you a little bit on CPU states. That information is also available in top.
And then in a very similar vein, we have iostat, which is input output.
Yeah, so in vmstat, it gave us some information on blocks in and blocks out across all the IO devices on the system. Here in iostat, we see that broken out a little bit more by device. And then also it gives you rates. So TPS is transactions per second. So you can see what your busy devices attached to the machine are. And then in addition to blocks in and out, that's the KB read and KB written fields towards the end. You also get a metric for time. So there's the KB read per second and the KB written per second. So it's telling you kind of the not just the raw amount of transactions that you're doing, but it's giving you that over a time sample so you can see how much you're doing by frequency.
Then the last one we want to talk about here in the critical path is strace, or system calls and signal tracing.
Yeah, so strace is used to either attach to a running process ID with strace-p, or you can use it to wrap a command. So for example, Eric, if you did a strace space ls, that would run the strace attached to the ls program. And strace is short for system trace. And what it's showing you is all of the system calls, all the system library calls that were made by this command. There's some other options for strace too, so you can have it not just show you the live information for how the system libraries are called, but you can have it count the system libraries they're called, and it'll just report kind of how many times a specific library was executed or how long it took for specific executions. So there's a bunch of options for strace. And the reason that we're putting it here in the critical path is that attaching this to a misbehaving or one that you suspect is misbehaving may provide some insight into why this application may be misbehaving. And Eric, I know that we installed the BCC tools on this machine as well. BCC tools, and we'll see if we can work them in a deeper dive, is a collection of applications that will do all kinds of performance gathering to provide more information about your system or about specific processes. I don't think we'll need to use them today in our exemplar broken boxes, but I always like having them because they provide a huge suite of performance gathering metrics.
Awesome. So that was a look at the 4 or 5 basic tools that you'll want to use for troubleshooting performance on your system. After the break, this will be the time to jump in and ask your questions and share your thoughts. And we'll also be switching over to a different box that has been pre-broken. And if Mr. McBrien is available after the episode, after the end credits, as it were, we'll dive in and we'll talk about what we did to break today's box. That's been an exciting segment that has been very popular over the last several episodes. So stay tuned after the break, and we'll dive in and talk a little bit more about performance troubleshooting.
Hey, Eric.
Welcome into the terminal 51. You got to do 50 all by yourself. I'm pretty jealous. Nate and I were offsite at AWS reInvent, so I think we both came back with a little bit of the conference junk, but mine was more related to it was warm and dry out at reInvent. I come back to Kansas City, it's cold and rainy, so of course I can't breathe again. So that was fun, but sounds like you had a great time on episode 50.
Yeah, I can't wait until we can do episode 100.
Well, let's not get there by doing like another 30 days of Into the Terminal twice a day.
Fair point. So you mentioned that we're going to be taking a look at a pre-broken system. I've actually broken it in a couple of different ways for us to troubleshoot. But before we get into like what's going on with the system and using the tools that we just talked about to find it, I want to first talk about what is performance. Because it turns out that, like, in my experience, systems are operating just fine, but people will say that they're not, or like they have these weird expectations. And so most likely, in my experience, the easiest thing to do to fix performance problems is to actually set people's expectations on what performance should be. And so, for example, if you ever use any of our online labs at lab.redhat.com, when you click start, it gives you a little spinny wheel, but it also gives you a time. And so, like, we're telling you, hey, it's going to be 2 minutes or 3 minutes to set this thing up, thereby setting your expectation for what the performance is. If you just hit start and it's a little spinny wheel, after about 30 seconds, you're looking at your watch going, gosh, how long is this thing going to take? The performance is terrible. And in reality, it's like, well, we're provisioning a box, we're starting it up, we're running a bunch of things to set up your lab for you. Like there's a bunch of things that are happening there when you see the spinning wheel, but we never told you how long it was going to take. And so you just drew your own conclusions for what performance should look like for that. And so like when I go to places where people are complaining about it's slow, that's my favorite. It feels slow. Well, you know what? Feelings are not facts. And so like figuring out what that is and why they have that expectation is typically the easiest thing to improve performance, because you're really just setting the expectation of what performance should be. But sometimes there's like legitimate degradation in what the system is doing. And as systems administrators or developers, we need to dig in there to figure out what's causing that degradation. So let's bring up the terminal here, and we will take a look at something that is broken. So for this system, I'm just going to do real quick an uptime. So I see something interesting in this uptime. Eric, do you see anything interesting in this uptime?
Oh no, looks fine to me.
Yeah.
Except for maybe the output there at the end of the line.
So this machine is having possibly an abnormal load average. So load average is one of those things where people, again, like misconstrue what the data means. So remember that what load average is telling me is the number of runnable processes in the CPU run queue over the last 1, 5, and 15 minutes. And then they apply a logarithmic algorithm on top of the actual raw data to smooth out any spikes that might have happened inside that sample period. And so that's why, like I know, for example, that we've been running the same processes on this machine for the last 1 and 5 minutes, and yet the differential between the 1 and 5 minute load average is there, right? And that's because of that like smoothing of spikes that's happening for the longer term load average calculations. All right, having a huge load average may not be a problem per se. It might be perfectly normal. And in fact, on this machine, right, when I do stuff like ls, df-h, like it seems really snappy. Right? We're getting responses back quickly. But it could be that that's not the case. It might be that you're working with it and it's like really slow. Like you type a key and then you wait and you wait and you wait, and then it shows up on the screen. And so that's what we're trying to kind of generate in terms of the symptoms that's not really affecting this box. And so after the episode's over, I'll tell you what I did and why it's not really affecting this box in that way. But it could be that like, you have 41 runnable processes, but you only have one processor or two processors. That's generally not a great look because you're like running around doing all the stuff all the time. All right, so load average. We could also see this with top, right? And I like top. It's always my first go-to when troubleshooting performance problems. And our top output is showing us something interesting as well. Do you see anything notable in there, Eric?
Yeah, normally I would expect things like systemd, maybe a web server, a variety of processes, both workload and system related. But in this case, I see a whole bunch of processes of DD, which is one of our disk write tools.
And so that's kind of interesting. And this goes back to something else that we've talked about in previous troubleshooting episodes, which is in order to troubleshoot something effectively, you have to know what normal looks like, right? So is this box normally coded in a pile of DDs, or is this abnormal? So today I'll tell you that it's abnormal. Like Eric's right, we should see things like other processes. In fact, we saw that earlier with Eric's top, right? There was a mixture of things that kind of bubbled up and down in the top, and that was kind of normal. And this is definitely abnormal.
Works on my machines.
So looking at, the other thing to look at in this is if you look at the, let me see if I can highlight it before it updates. This field right here, the state field, all of these processes are in the runnable state, right? R. And this is actually what's causing that huge load average, is that all these runnable state processes are sitting there being run by the CPUs, and because there's so many runnable processes, that's what's generating the load average. All right, so at this point, we kind of see what's going on, and we could look elsewhere on the system to see if there are any terrible effects. So in addition to things like the fact that we have a high load average, the other things I would want to look at are things like this bit of top. So Eric, we are pretty heavily used. In fact, if you look at the ID field, you'll notice it's 0. That's kind of concerning, because what is the ID field telling me?
It's idle, isn't it?
Yeah. Eric, by the way, didn't know that there's going to be a quiz today. So I'm putting him on the spot. So we can see that we are 50%, 51% user processes. That's the US. We're 47, 48% system processes. That's the SY. There's 0 nice, 0 idle time, and 0 IO wait processes. All right. So one of the reasons why our program was still kind of snappy, right, where our box still is responding pretty well, is because these processes are using user space processing or processor categorization. And so we have things like nice and a process prioritization to make sure that not a single person can starve out everyone else on the system. So even though all these jobs are running, like we're still sharing the system with our multi-tenant model for Unix and Linux. Okay, so Eric, maybe we've decided that, okay, DD is the problem. I know what is causing this DD. Turns out I had a shell script that went kind of bonkers, and it created all these things. And it's a mistake. Like, I don't want all these things. All right, so is there a simple and easy way that we could get rid of all of those things?
So we could actually try and track down the process IDs, but that would be very manually intensive. But we could actually look up the command name and do a kill on all those running processes.
Yeah, in fact, we get that output from top, right? So if you wanted to kill by process ID, there's the process IDs there in the first field. And if you wanted to do something like a kill all on a command name, there's the command name there at the end, right? So what I'm going to do is a kill all DD. All right, so we've terminated them all. And when I look at my top now, right, they're all dead. And over time, I will see my 1, 5, and 15-minute load average values start to go back down as we get to like a more sane state of system running. So I fixed the problem, right? But I did it in a really heavy-handed way. Right? Just like killed everything that was DD. But what if that was actually like a real process running on my system, doing real things, and now I just killed it? I mean,
well,
it
I'd
was doing
imagine
something.
your boss is probably calling you and chewing you out for his multi-hour processing job that you just murdered.
Yeah, maybe. So before you use something as heavy-handed as like a kill all, where you start killing random processes, you should probably stop and think about, what is this really doing? Why is it here? What is the meaning of life? So that you can better answer that question and like decide whether that's really the route that you want to take. All right. So on that, our next exemplar is how you could actually figure out what those processes were doing. So I have a command that will show you what programs are doing in real time. Eric, it's the quiz question time.
Oh, no.
What question would I use, or what command would I use to attach to a process to figure out what it's really doing live?
I'd use strace.
Yeah, strace, exactly. And so let's do a problem where we can use strace. All right, so
Whoever said I couldn't cram before a test.
I mean, these are just all things you naturally know, Eric. It's built into your long-term memory. Okay, so here I am running curl to try and get the homepage for Google. Man, that's taken a really long time, but I mean, eventually I got it. All right, and if I do it again, man, that's taking a really long time. Seems like a performance degradation on my machine. I expected that to be like real fast, but it's taking a long time. All right, so what we're going to do here is we're going to wrap this command with strace so we can get a list of like what it's doing. All right, I will warn you in advance. Strace is super, super ugly. Super ugly. So it is going to freak you out the first, I don't know, 50 times you look at its output. It's important to note, what are you looking for in strace? You don't have to know what every single system call does. You don't have to know what like every single argument does. What you're looking for is what's the kind of observable pattern that you're seeing in the application. Okay. All right. So here we go. We're going to strace. All right, so I took the previous command I was running. I just put an strace in front of it, which is going to strace wrap it. All right. Okay. So you probably didn't notice anything if you're new to strace. You're like, yeah, there's some gobbledygook on the screen, and we got more gobbledygook, and then, yeah, it exited. Okay. But in reality, what you may have noticed was it started off really quick with a bunch of different gobbledygook, and then it like kept repeating the same thing for a while. And then it switched back to all different gobbledygook. All right, so let me scroll back up through this output here. All right, and this is probably far enough. Okay, so when I'm looking at this output, I'm seeing a open AT call. And in the arguments for that open AT call, I see user lib locale enus something something. And then the next section down, I see an open AT user lib locale enus something something. And I'll keep scrolling down through these open ATs. Okay, and then I see this one right here. So you may not have recognized the other user lib locale something somethings, but here is a file that we might recognize what it is. So then we have an open AT for /root/.curlrc. And so this is a local configuration file for root that customizes how curl commands run as root should be configured. So what we're seeing with all this like series of open ATs is the curl command opening up different files on the system to read in data. And if we go backwards through the other ones that we were just talking about, it's things like loading the language kit for numbers, loading the language kit for money, loading the language kit for lowercase characters, right? So all we're doing is like opening and reading files. That's what we're seeing here. And then in this this opening and reading of files, that's just setting up the kind of environment for curl to run. All right, then we see something different. So we saw like a block of kind of similarly formatted stuff, and we traced through it, and we saw what it was doing. It's like, okay, setting up the locally running environment for curl. That's cool. Then we get to something a little bit different. So we get down to like here. Socket.
I see networking things I recognize.
Yes, that's exactly right. So we were doing file things, and now we're switching gears and we're doing some networking things, right? Because sockets are a way that we communicate via network connections. All right, so we do some socket networky things. Okay, and then down here, we see another block that's kind of like all the same. Pole. What do we think might be going on here?
We're taking a survey.
I know. I mean, that's not far off. We're checking to see if something is out there, right? We're actually interrogating something to figure out if there's been a change in state. So we did some networking things, and then we're doing polling, right? Where we're timing out, and we're checking it again, and we're timing out, and then we're checking it again, and we're timing out, we're checking it again. And after a whole bunch of that, then we start to see some other stuff like this. So what do you think we're doing here?
So we were opening up a socket, and then we did some polling, and now we're doing a connection to a public IP address that starts with 64.233. I didn't know this was also going to be an iTest today. So I mean,
All right.
connect. That's good. We're trying to connect to something.
Okay. So let me go back and show you the behavior of our application one more time. Okay, so we're doing something, but it's taking a while. And then we're able to connect and actually download the page for Google. So what we're looking
Considering
at
the
is
number
like,
of times we did a poll, I would start to assume that something in that chain of events isn't responding the way we would expect it to, if responding at all.
exactly. And in fact, that's what we're seeing in this slowdown, right? So while we're waiting, for this curl to resolve, that's the polling that's happening and the timeouts that are happening as we continue. And then something happens and we get our connection that we saw to that 64 dot something something IP address. The audience is on fire. All right. So indeed, it is a problem with DNS. But that's kind of beside the point. The point was we're using this tool to figure out what is happening on this machine. Like, where is it spending its time? What is it doing that's causing this behavior that we're seeing? Okay. So the fact that we did all the setup stuff for curl very quickly, and then we started having problems while trying to make network connections, that would redirect me into the networking troubleshooting. We had another episode where we talked a whole bunch about networking troubleshooting, so I will not go back into that. You can refer to it at your leisure. And it turns out that the problem here is DNS. So if we look at etcresolve.conf, the reason that we're getting the behavior that we're getting is because the way that DNS resolution works is it tries to connect to the first name server listed in this file. And after it's unable to do so, it will then move to the second name server in this file. And so I purposefully put in a bogus name server that I know would not respond so that it's like trying, and that's where our connects and timeouts are happening, where our polls are happening. And after a while, it gives up and moves to the next DNS server, which immediately responds with a valid value. And then we connect to Google and we see their site. So that's what's happening there. But the point is, strace is what helped us determine that, right? Because if I fix this and I run the same strace on my curl again, Notice that there was no slowdown. There was no series of repeated polls after we tried to make a network connection, right? So looking through the strace and kind of seeing what it's doing is what allowed you to very, very specifically, Vincent, point to it and go, it's DNS. All right. As I mentioned before, you can use strace to connect to running processes. So let's see here. What do we have here? Nothing really interesting. Why don't we go to systemd, perhaps? All right, so here we are attached to the systemd daemon, and it's just kind of hanging out, waiting for something to do. So that's why it's in the epoll wait. And then once something happens, like a service gets restarted or whatever, then we'll see a whole pile of strace messages.
Like
right?
that.
So it did some stuff, and then it's back in epoll wait, waiting for an event to occur. And then it did some stuff, and now it's waiting for an epoll wait. So this is really handy when you have a running process, not a wrapped process, right? If something's happening on the machine, you want to know what's going on with it, you can just like stick an strace to attach to it. All right, and Control C will detach you from the strace. All right. I also wanted to call our attention to one other pretty handy troubleshooting tool. So Eric, I'm going to change my screen. This one. So why don't you tell us what we're looking at here, Eric?
We are looking at the one and only web console. So along with the terminal, you actually do have a web-based graphical interface where you can go in and manage Red Hat Enterprise Linux. It's based on the Upstream Cockpit project, and I believe we had an episode of this show dedicated to web console. But I know for today's episode, we want to focus specifically on the metrics and history page. So when you log in, you initially get dropped into a dashboard that shows you any alerts, our health, our current utilization, some basic systems information. But in that second box there, we see usage. And what you're looking at is basically an output of currently looking at an output of the load average. So you notice that we fixed the whole DD pile of processes. So we're currently not running any load on our CPU. But one thing we might want to look at is we can click on View Metrics and History, and that loads up a series of graphics and charts that help us drill down into specific issues. We can see what the read-write is on our disks, what our networking traffic looks like, inbound and outbound. We can see what processes are actually using virtual memory, as well as CPU. And if you scroll down, you actually get a is it not a burn down chart? You get a pretty graph that shows you the spikes in CPU or networking. In fact, there was a network spike a few seconds ago, and some CPU traffic that went with it. And on the left hand side, what it's actually doing is it's showing you snippets that might be of interest. So it showed us the network I/O spike, and fortunately, I can't read that from the window that I've got pulled up, but it may give us some indications as to what it did. There we go. Just resize my window here. Looks like that's what I get for trying to guess live on air. But it'll actually pull out individual points of interest when there's a spike, a sudden increase in activity, and you notice that across that top bar, it actually says View Detailed Logs. So what we're looking at is actually a conglomeration of a ton of different tools, some of which we looked at, some of which are included in the BCC tools, So we can actually dig in a little bit deeper. You can change the time box. You can change the level of information, whether it's just info level or warning level, all the way down to say even debug level if you've got that enabled. Scott, I know that BCC tools is something that's near and dear to your heart.
Yeah, but we're kind of at the limit of our time together. So just to like tie off this a little bit more, it highlights, you can see like load spike, CPU spike, network IO spike. So when the system detected problems using Performance Copilot, it highlighted that. You can see in the usage data, that's actually being driven from real data on your system, like load average information. You can see that it like went up, and then after we killed off all those DDs, it went down to 0. So it's graphing that data to make it a little bit more easy to interpret. When it found those interesting things, it aggregated a bunch of information from different logs into this small list of kind of like giving you a snapshot of what was happening on the system when it detected this state. And then, as Eric mentioned, you can go to view detailed logs, which takes you to the log viewer included in Web Console, where you can go into a lot more depth and see everything, not just the curated messages that Web Console has picked out for you. So if you're starting, like I always start with top, maybe I should actually start with this. So if I was running a Web Console, maybe I should start with looking kind of like what's going on in my system lately. Oh, some spikes? Let me take a look to see if there's any interesting log messages around these spikes before jumping into top and strace and some of the other tools.
Awesome. So we are at the end of our time together. Thank you all very much for joining us live, for watching this after the fact. Make sure to like and subscribe this content, share it with a friend. Next week, episode 52, we'll be wrapping up our troubleshooting arc and our live streams for the year. This will next Into the Terminal will actually be the last of 2022. I cannot believe it, but we're going to try and pull together some common user error problems. So I typed this thing wrong and something broke, how I fix it. So that'll be interesting as we try and pull together some things that we've pulled off social media, off of blog posts that we follow, and from some of our fellow Red Hatters. So with that said, Scott, thank you so much for... I'm going to move to the desert.
Well, how about I take us home then, Eric? Thanks, everyone, for joining us today, and we will see you next time for another Into the Terminal, hopefully another troubleshooting one, and we will carry on from there. Have a great end of year, everyone.
Thanks, everybody.